Welcome to the project demonstration of battery management system along with SOC and SOH calculation with thermal protection. So here the main application of this project is we are going to continuously measure the battery voltage from this battery pack and also temperature near this battery pack, and also from the battery voltage we are going to estimate the SOC SOH values, that is state of charge and state of health. State of charge nothing but whenever we are providing charging to this one battery, then how the battery charging increases based on the charging inputs. So if it is increases slowly, then the SOH values will be comes down from 100% to lower, and if it is normally increased level, then it's going to be the 100% nearby 100%. Same for SOH also. So when the battery is in idle state, if the battery voltage is drastically decreases, then the SOH values will be affected and will be comes down from 100 to 90, 80, 70 like that, based on the rapid drastic voltage levels inside the battery when it is idle. And this is continuously monitored by the PIC microcontroller PIC16F73. We are using continuously measuring the voltage from this voltage sensor. They we are using the two resistors which are connected in series input to the 12 volts battery input, as it is going to be the 10:1 potential divider voltage ratio. Nothing but whenever the 10 volts is coming from this battery pack, then the microcontroller will get the 1 volt, as we are getting the voltage across 1 kilo ohm resistor, and that is a 10:1 voltage ratio. And inside the microcontroller we programmed it with multiplying the input voltage at A0 pin analog voltage, that will be multiplied with 10 times, as we are using the 10:1 potential divider voltage ratio purpose here, and which was interface this to the A0 and A1 to the temperature sensor. This is a temperature sensor which is continuously monitoring the voltage levels, current level, temperature from this battery pack. And we have interfaced the electromagnetic relay which will take input from this charging circuits to the battery, which is in series, which is acting as a switch here, and we have interfaced that at pin number C7, and port B2 to B7 interface to the LCD which is continuously monitor the voltage, temperature, SOC, SOH values. And we have interfaced the buzzer which will provide us audible alerts whenever the temperature of this battery pack exceeds 43 degrees centigrade, then it will provide us the audible alert through this buzzer. We have interfaced this at pin number C4. Coming to the components: buzzer, microcontroller motherboard, LCD display, electromagnetic relay, 12 volt 1 amp battery pack, voltage sensor, and regular power supply board. And this is a transformer which will take 230 volts AC input and provide us the 12 volts AC output, that is input to this regular power supply board, which has the 3 stages. One is rectification to convert the AC to pulsating DC, filtration to remove the pulses and provide us the 12 volts constant DC, and after that we will use a 7805 regulator which will take 12 volts DC input and provide us the 5 volts DC output. And 12 volts DC is parallelly connected to the battery pack through this relay, and 5 volts DC directly connected to the motherboard which will operate at 5 volts of DC power supply. Just on the power supply, then welcome message displayed on the LCD screen, and thereafter the voltage will be calculated by the sensor. That's 12.5 is the battery voltage, and degree centigrade 29 degrees centigrade is the temperature, and SOC SOH values will be calculated around 10 to 15 seconds gap. Right now we have got the SOH, state of health is 92% and state of charging is 100%. Now just we need to make the voltage fault. So to make the voltage fault, just you can disconnect this 2 pin from the voltage sensor. Nothing but we are making the voltage as a 0 volts, which is less than 8 volts. So if the battery voltage is less than 8 volts, then system will on this relay to make it is charging till it reaches above 11.5 volts. So whenever the voltage from this voltage sensor reaches 11.5 volts, then automatically it will switch off this relay to stop the battery from overcharging. So we are on this. Then the voltage is 13.1. As before that the battery got charged, and now the relay got switched off. Same thing for the temperature sensor also. So when we place the increase the temperature sensor, when it is crosses 43 degrees centigrade, then it will provide us the audible alerts through the buzzer, and high temperature message will be displayed on the LCD screen. Right, thank you.